All right, we're going to take a look at our first conic section here, which is parabolas. Here I just have kind of the picture of the basic parabolas and their formulas. So we're seeing this A value here. I just want you to note that the A value is the distance from the directrix to the focus. It's also the distance from, the directrix to the vertex. It's also the distance from the vertex to the focus. So that is the significance of that A value. The point H comma K is the coordinates of the vertex. Okay, and what we're going to do is kind of look at some examples and see if we can create these equations based upon the examples that are given. So an important thing to do is to kind of draw a picture of these so we can visualize and locate the directrix, the vertex, and the focus. Find the equation of the parabola described. Vertex at 4, -2, focus at 6, -2. So if we draw a little sketch, we can decide based upon the picture whether or not the parabola is upward and downward facing or left or right facing, just based upon the relationship. So the vertex is located at the point 4, -2. 4, so here is the vertex. The focus is at 6, -2. So the vertex is actually a point on the parabola. The focus is not. The focus is located inside the parabola. Because the distance here is 2, we already know the value of A. This means that A is 2. That also means that the directrix must be over here to the left, also 2 units away. So the directrix would be right here, also 2 units away from the vertex. So this directrix would have equation x equals 2. That's not super important for finding the equation, but it is useful to note that. So we can tell from the picture that the parabola faces to the right, so something like this. It's just a sketch for information purposes. We weren't necessarily needing to make an accurate graph. So because the parabola is facing right, I know that this is the basic form of the equation. Y minus k squared equals 4a times x minus h. So it's positive 4a because it's facing to the right. I have h and k right here. H is 4, k is -2. So we can go ahead and plug those into the equation. We also have the a value right here. A is equal to 2. So I have y plus 2 squared equals 8 times x minus 4. And that is the equation of the parabola described. Let's try one where we're being given a little bit different information. The focus is at the point -4, 4, and we've been given the directrix. This time the directrix is a horizontal line. So let's draw a little sketch of this. So let's draw on the directrix. It's the horizontal line y equals -2. We also have the focus at the point -4, 4. So -4, 4. Okay, now neither the directrix nor the focus are actually parts of the graph of the parabola, but I do know that the vertex should lie directly between the focus and the directrix. The focus and the directrix are 6 units apart. We can see that right here. They're 6 units apart, which means our A value must be 3. So that means my vertex must be right here at the point -4, 1. So I do need that vertex in order to populate the equation of the parabola. So the parabola looks something like this. Doesn't really matter exactly what it looks like, but I know that it is upward facing. I can see the A value here is 3, right? Because we saw that 2a was 6. So let's go ahead and write out the general form of the parabola first. It would be x minus h squared equals 4a times y minus k. I know this is a positive 4a because the parabola is facing upward. Okay, so now I can fill in h and k and a. We found all those things in this little sketch. So it's going to be x plus 4 squared, right here we have h, equals 12 times y minus 4. Here we have k. So this is the equation of the parabola with focus at negative 4, comma 4, and directrix, the line y equals negative 2. Okay, so let's say we have an equation. Can we locate the focus, vertex, and directrix? First of all, looking at this equation, you can see that it's not in standard form. I'm seeing an x squared, so I know it's either facing up or down. Can't really tell yet. What we need to do is to complete the square to get this into standard form. So let's go ahead and keep all the x terms together and move all the other terms to the other side of the equation. I'll add 4y and I'll subtract 1. So what we need to do is complete the square for x in order to get this into the standard form of a parabola. So we've completed the square a few times. Here's our b value 6. So we're going to do 6 over 2 squared, which is 9. So we'll add 9 to both sides. Okay, the purpose of adding 9 to both sides is that now we can factor over here as a perfect square trinomial as x plus 3 squared. And over here, we'll just combine like terms. Okay, it's almost in standard form. The last thing we'll need to do is factor out whatever coefficient we have here on y. In this case, it's a 4. So x plus 3 squared equals 4 times y plus 2. Okay, so now we can see h and k, right? So x minus h, y minus k. So the vertex would be the point negative 3 comma negative 2. This here is 4a. It's just a 4, so we can get from that a is equal to 1. The a value is important because it's the distance from the vertex to the focus and the directrix. So let's go ahead and start piecing it together in the picture, and then we can start writing out the other things we were asked to find. So the vertex is the point negative 3 comma negative 2. The a value is 1, so the focus will be 1 point or 1 unit above. Here's the focus. The directrix will be down here, 1 unit below. And then the graph, I don't really know what it looks like. Something like this. This is our upward facing parabola. So we can find now the focus and the directrix, or at least give the coordinates of the focus. It looks like it's the point negative 3 comma negative 1. And the directrix is the line y equals negative 3. So now I have all the things that we were asked to find. A similar example here, except now we're seeing that the y is being squared, which means this parabola will either face left or will face right. We will complete the square here for y. So this is the b value, negative 2, so we want to add b over 2 squared. Negative 2 over 2 squared is positive 1, so we'll add 1 to both sides. So the point of completing the square is we can now factor this as a perfect square trinomial, so it's y minus 1 squared. Over here I have 8x minus 1 plus 1, that's just going to be 8x. Okay, because this is positive, this means my parabola will be facing to the right, like this. I can now figure out the vertex. Here is my k, it's 1. Nothing is being subtracted from x, which means that the h value is 0. So let's write out the coordinates of the vertex. hk, it'll be 0, comma 1. Okay, this right here is 4a. It's 8, so that means that a must be 2. The a value kind of tells me the distance between the vertex and the focus and the vertex and the directrix. Let's start putting this together in a graph of this parabola. So I have the vertex at 0, 1. I know that it opens right because of the standard form of the parabola, so the focus would be over here, 2 units to the right. And the directrix would be the vertical line, 2 units to the left of the vertex. So the parabola looks something like this. Okay, so let's go ahead and write out our focus and our directrix. So the focus will be the point 2, comma 1. Okay, it's 2 units to the right of the vertex. And the directrix will be the vertical line, x equals -2, which is 2 units to the left of the vertex here. Okay, one more example here where we just have a graph of a parabola and we're being asked to find the equation. Just based upon the way that it looks, I know what the standard form of the equation will be. I know it will be y minus k squared equals -4a times x minus h. And I know that because it's open left, that the y is being squared, and that this expression here will be negative because it is facing to the left. Okay, I do also see the vertex here. H is 2, k is 0. So I can go ahead and plug those things in as well. K is 0, h is 2. All right, now I need to solve for this a value here in order to have the equation. I have one additional piece of information. The point -2, -2 is on the parabola. What I can do is, because they're on the parabola, it should make the equation a true statement. I can plug those in for x and y and use that to solve for a. So let's go ahead and do that. -2 squared equals -4a times -2 minus 2. 4 equals -4a times -4. Okay, and keep going. 16a divide 4/16, that's 1/4. So a is 1/4. So let's go ahead and plug it into the standard form. So I have y minus k squared equals -4 times 1/4 times x minus 2. -4 times 1/4 is just 1. So the simplified version would be, oops, I didn't mean to write a k there. That's right. Just y squared. Y squared equals -x minus 2. Okay, and that is the equation of the parabola in the picture. Next, we're going to look at a couple of application questions where parabolas would show up in the real world. One example is in the structure of a bridge. The cables of a suspension bridge are in the shape of a parabola. The towers supporting the cable are 400 feet apart and 100 feet high. If the cables are at a height of 10 feet midway between the towers, what is the height of the cable at a point 50 feet from the center of the bridge? Okay, so let's go ahead and start labeling here with the information that was given. The supporting towers are 400 feet apart. Okay, so this is 400. It says they are 100 feet high. So that is starting from the bridge. So let's decide right now to just make the bridge itself the x-axis. Okay, so I know that from the bridge to the tallest point on the tower is 100 feet. Okay, it says the cables are at a height of 10 feet midway between the towers. So midway between the towers, about right here, the cables are 10 feet from the bridge. So let's decide right now to make that into the y-axis, just for ease of assigning an equation to it. So that means the vertex here would be the point 0, 10. So now that we know the vertex, we have an h and a k. Okay, so let's see if we can start to write out a standard form of this parabola. It's upward facing, so I know it has this form. X minus h squared equals 4a times y minus k. Well, I have h and k. H is 0 and k is 10. So x squared equals 4a times y minus 10. We're creating an equation so we can use it to answer the question, but in order for the equation to be complete, we need to solve for a. We have this additional information about the height of the towers, so I can actually label this point here. This is midway between the towers, so the x value would just be half of the 400, so 200. And the height would be 100 because they told us the tower is 100 feet high. So we can now replace that for x and y in the equation and solve for a. So let's go ahead and do that over here. So I'm replacing x with 200. And I'm replacing y with 100. And then we can use it to solve for k. So 200 squared is 4 with 4 zeros. 1, 2, 3, 4. So I guess that's 40,000. 100 minus 10 is 90. 90 times 4 is 360. Okay, divide both sides by 360. The fraction on the left can reduce by a factor of 4 on top and bottom. Actually, say 40. So we could get a reduced fraction of 1,000 over 9. And that is equal to a. And now that we have the a value, you can write out the complete equation of the parabola. It is x squared equals, let's see, 4a, so 4,000 over 9 times y minus 10. Okay, so the whole point of getting that equation is now we can answer the question. What is the height of the cable at a point 50 feet from the center of the bridge? It doesn't matter if you go left or right because a parabola is symmetric, fortunately. So we can choose to plug in a positive 50 for the x value. So it's talking about, let's see, something about right along here. What's this height? And that would be an x value of 50. Same on the other side, so negative 50 would also work. So let's just plug in positive 50. And then we'll solve for y, which would be the height of the cable. So we can multiply by the reciprocal, so we'll have 9 4,000ths times 50 squared equals y minus 10. So maybe a 9 4,000ths times 50 squared plus 10 equals y. And if you put that in a calculator, you get a y value of 15.625 feet. So that's one application of parabolas. Another one is the shape of a lens. The shape of a lens is, in a telescope, is the shape of a parabola. The actual three-dimensional version, which you can see over here, is really called a paraboloid, and you will study paraboloids more in depth in Calculus 3. For now, we'll just look at the cross-section of it, which would be a parabola. So it says a reflecting telescope contains a mirror shaped like a paraboloid of revolution. If the mirror is 4 inches across at its opening and 3 inches deep, where will the collected light be concentrated? And then it's actually will be concentrated at the focus. It's kind of one of the reasons it's called the focus. So let's draw just a cross section of that. We'll strategically place the vertex at the origin in our graph just to make it easier to create an equation. Okay, so it was my choice to put the vertex at the origin. It says the mirror is 4 inches across the opening, so from here to here is 4. So I can tell right now that the x-coordinate of this point will be 2, the x-coordinate of this point will be negative 2. It also says it's 3 inches deep, so the y-coordinate for both of these will be 3, because I know that the depth of it is 3 inches. Okay. I have the vertex here, it's 0, 0. So because this is an upward facing parabola, I do know the general form of the equation will be this one. X minus h squared equals 4a times y minus k. I already know that h and k are both 0, so x squared equals 4a times y. I need to solve for this a value to find the focus because the focus will be a units above this vertex. I just don't know exactly how far that is yet. I can solve for a by plugging in 2, 3 for x and y. So I get 2 squared equals 4a times 3. So 4 equals 12a. Divide both sides by 12. 4/12 is the same as 1/3. So 1/3 equals a. So that means the focus is 1/3 inches above the vertex. So the focus will have the coordinates 0, 1/3. And the light will be concentrated 1/3 of an inch above the focus. Oops, I spelled light wrong. The light will be concentrated 1/3 of an inch above